Good morning, everyone. So this experiment we are going to do is about IR. Okay. So as we know that we cannot do it the experiments in the lab right now. So we are going to explain you the theory over here. All right. So you can take the notes later on from the video for your learning, and we will show the experiment over here. We will run it and we'll record the video for you. So these both sensors, IR and sonar, okay. Although we are going to do experiment in the first video only for IR, but we need to explain the differences between these two sensors or how this to work. So for these both sensors, IR and sonar, they both are basically a distance measure sensor. The most common application for these both sensors are to measure the distance. Okay, how these sensors work? That these sensors, they have a transmitter, okay, and then they have a receiver. So they transmit a signal, okay, and the signal will be bounced back after striking it with the object, and the receiver will measure, it will calculate the received signal voltage, or you can also say the output voltage, and after comparing the output voltage and the input signal voltage, it will decide that how far its object is. So you can see the distance is calculated by sensor on the basis of voltage of reflected signal. This is how generally these sensor will work. Okay, but now in a very logical way of thinking of this, that like if I'm saying if the output voltage, or if the voltage of the reflected signal is less than the input, it means I can say that the object is far. And if the voltage is increasing, if the voltage is increasing, I'm saying I can say that object is coming near. If the output voltage is decreasing, I can say the object is going forward. This is how the most general way of thinking it. Okay, but there is a range of operation. This is the difference. That if the distance between object and the sensor is less than 15 centimeter, it is vice versa. After 15 centimeter, it will be the same as it is. Like this is the range of operation for IR sensor. When the object goes from 0 to 15 centimeter, the output voltage increases. Means what he is saying, that if the distance between object and the sensor is less than 15 centimeter, and if I'm moving object away from the sensor, the output voltage will increase. So it's basically the vice versa. Usually we just said that if the object moves away, the output voltage shall decrease. If the object comes near, the output voltage shall increase. But within the range of 0 to 15 centimeter, it's other way around. Means if the object moves away, the output voltage will increase, as is written over here. When the object goes from 0 to 15 centimeter, the output voltage increases. After 15 centimeter, it's normal. After 15 centimeter, the output voltage will decrease as the object moves away. Means if I go away from the 15 centimeter range, now if my object is moving away, the output voltage will decrease, and as my object is moving near to the sensor, the output voltage will increase. But after once it's crossed 15 centimeter, so this will be the other way around. So you can memorize this thing, the rate of operation. When object goes from 0 to 15 centimeter, the output voltage increase, and after 15 centimeter, the output voltage decrease as the object moves away. Okay, now there is one more question, that we just said that these are the both sensors, IR and sonar. So when to use IR sensor to measure the distance, and when to use sonar? Okay, so they both have advantages and disadvantages. First of all, for IR. IR is basically used for short range distance measurements. This is the main application for this sensor, IR sensor. The reason is that's because it is more precise. Means it can give you accurate distance up to centimeters. So this sensor is more precise. That's why it is preferred for short distance measurements. Okay, but the disadvantages for IR is it is not suitable for long distance measurement. Now this disadvantage is basically the advantage of sonar. Sonar, even if you must have heard it, even in movies or some places, that in the submarine they use sonar signals, right? Because it can travel for the longer distances. So this is the advantage of sonar, that it is more suitable for long distance measurement. Now, when you are measuring long distances, let's say in meters or kilometers, you are not worried about centimeter. Okay, so this is basically the disadvantage of sonar, that it is less precise. So even you are measuring the long distances, you are not this much worried about the centimeters precision or not. Okay, so the advantage of sonar is what? That it is suitable for long distance measurement, and what is the disadvantage? It is less precise. So these are the advantage and disadvantage, or the difference between IR and sonar sensor. Now it's up to you. It's basically the application dependent, that when to use sonar and when to use IR. Pause. Okay, so this is, we are using again exactly the same board. Now you guys are familiar, this is the same thing you've been doing before as well with other experiment, with other sensor experiment. That first of all you need to put the jumper on infrared. This is the infrared, you can see from here, infrared. So I need to put the jumper over here, and this is the IR, so I need to turn it on. So it's already on, so you can see this is transmitter and this is receiver. All right, so and the experiment is exactly the same way that you've been doing before. Means you need to do the programming of, and of course you are doing it remotely, so you cannot do the programming. So I will, we have done the programming for you and we'll show you it's working. So this will be my block diagram, and there will be two tabs for the front panel window. One will be the collect data, other one will be the calibrate sensor. And after completion of this thing, this will be like this. So I mean, this is my block diagram, right? This is exactly same the block diagram what's been done over here. And this is my front panel window, both tab, collect data and calibrate sensor. So for the timing I will just stick to this. Okay, now before that, all right. Now again, this is exactly the same thing, guys, that we've done. We put the Labview. This is the read module, which is going to physically read the voltage from the sensor. Okay, then do the calibration and everything. And these are the, again, this is the polynomial fit module, which is going to give you the coefficients of the characteristic equation of the sensor. And as we know that all the sensors, they work on the basis of characteristic equation, and once you have this coefficients a, b and c, we will plug in there, because the characteristic equation is ax square plus bx plus c. So this is ax square plus bx plus c, and this will result will be shown in IR sensor. The distance will be shown over there. Okay, so we will select the device. Okay, and again this is the same thing, that you have two arrays, one for the target range and one the sensor measurement volt. We have done this, we have uploaded it for you. So I will select the device from here, it's already selected, and then I will run it. So basically after getting this thing from the target range, we have get these voltages values from this infrared voltage, and this is the coefficients of the characteristic equation. We got it from here. So we will copy it one by one. A will be here, and then we will copy from here. B will be here, and this is the C. Okay, so you can see, you can take the readings for this, if you can zoom in for these. This is the target range array, and this is the sensor measurement volt V, and these are the generating coefficients. A is 4.51, B is minus 40.13, and C is 90.41. We copied this over there one by one, and now I have this thing. See, now if I'm taking my, see, if I'm moving away and near, these readings are changing over here. You can see exact reading from the graph, and from this one as well. Let me see, if I'm removing my hand, it's almost 100, because there is some object which is almost 100 centimeters, so it's taking the reading from that. But if I'm bringing my hand near to that, see, this one is, this is decreasing. All right, so you can take note for these readings for your lab experiment. Okay, means over here, and then you can answer these questions as well. Again, I know it's better to do it in the lab. It's very hard to understand this remotely, but this is the only resource we have. This is the only way we can teach you right now under these conditions. So just take notes of these things for your lab report. Okay, of course, you don't need to again submit me the lab report. Just keep pasting the data in the experiment from the blackboard and keep it safe with you, so that once inshallah I'll come back, we can refine these lab reports, and then you can submit it. Okay, thank you.